Okay, last video. So what we've got to do is we've got to find the angle between these two lines. So now if we say we've got a line here and a line here, all that matters if we want to find out the angle is the direction of the line. Okay, nothing else matters. So what is the direction of line 1? Well, the direction of line 1 is -3, 1, -2, because we should understand that that is the bit that is the direction of line 1. Okay? And what is the direction of line 2? Well, we should understand that it's these bits that are the direction of line 2, but we've got to do a little bit of mucking around here because we've got 1 minus x over 3. We have to change it. So that would be the same as saying x minus 1 over minus 3 if I times top and bottom by -1. And that's going to be y minus 0 over 0. And that's going to be z minus 2 over -2. So you have to be really, really careful. Make sure you change it into the right form. Once you do that, it's very obvious that this is the direction of that line. -3, 0, -2. Okay, so all you need to do is find out the direction of the line because nothing else matters in terms of what the angle between the two lines will be. So we've got my two vector directions, so we can use the formula cosine of my angle is equal to the dot product of the two angles divided by the product of the magnitude of the two angles. So dot product is going to be 9 plus 0 plus 4, it's going to be equal to 13. Okay, and the magnitude of A is going to be 3 squared plus 1 squared plus 2 squared square root, and 3 squared plus 2 squared for the magnitude of the direction vector of line 2. So it's going to be 13 over 9, 4, 14, root 14, and 9 plus 4 is root 13. Okay, so that's what cosine of your angle is. So now just use my calculator. So 13 divided by root 13 times root 14. Okay, and then cosine to the -1 of your answer, I'm getting an angle there of 15.5 degrees to 1 decimal place. Okay, so that's how that is done. Okay, so stop your video and have a go at finding the angle between these two lines. Okay. I hope you've had a go at that. So hopefully you realise that these are actually only in 2 dimensions. You've only got x and y. So we could write this as x, y. Let's just do it in vector form to just find that a little bit easier. It's going to be 2 minus 1 plus t times -3, 1. Okay, that's going to be the vector equation of the line 1. And line 2 is going to be x, y is equal to 1 minus 4 plus s times 2, 3. Okay? Which means that I now know the direction vectors of my two lines. So the cosine of my angle is going to be equal to the dot product of the two direction vectors, which is going to be -3 times 2 plus 1 times 3 over 3 squared plus 1 squared square rooted times 2 squared plus 3 squared square rooted. So that's -6 plus 3 is -3 over, that's going to be root 10, root 13. Okay, so again, using my calculator, -3 divided by the square root of 10 times the square root of 13. Okay, and then inverse cosine of your answer. Okay, theta turns out to be 105.3 degrees to 1 decimal place. And of course, that's the obtuse angle. If the question had defined they wanted the acute, it'd be 180 minus your answer, which would be 74.7 degrees to 1 decimal.